In August 2020, the largest civil explosion on record caused almost immeasurable damage around Beirut's port, leaving no building, street, or community in its vicinity unaffected. Many buildings were severely damaged, and entire streets in the nearby neighborhoods of Quarantina, Gemese, and Mar Mihail left in rubble, disrupting community networks and leaving the businesses that served them in debris. A large number of buildings were left uninhabitable. Many businesses closed and have yet to reopen, and the added impact of the COVID-19 pandemic has been felt with restrictions on open spaces. The blast of 2020 also added to pre-existing urban planning and public space challenges in Beirut. The Lebanese capital on the Mediterranean coast has all the critical prerequisites to make it a highly walkable city. It has a great climate. The city is dense with a diverse and mixed land use pattern, and many small businesses line city streets. Yet, due to complex challenges, Beirut has largely failed to deliver walkable streets with safe and comfortable sidewalks. Many streets lack proper sidewalks. Where sidewalks do exist, they're often narrow or blocked by cars and other obstructions. Crossing busy roadways can be a frightening experience with no pedestrian signals and safety islands, and a lack of trees and shading make the thermal comfort a real challenge for pedestrians. The city's current mostly informal public transportation system is inadequate for pedestrians on longer journeys between neighborhoods, and the high increases in fuel prices have made travel by car unaffordable for many.
So walking is not considered as a mean of transportation in Beirut street. Cars are taking the most spaces on the road, on the street in Beirut. Beirut street are not considered accessible, especially for people with disability. Commuting in the public transportation in Beirut need safer bus stops and safer crossing in general.
Beirut has many challenges related to walkability, but at the same time, there are several factors in place that could make the city potentially highly walkable. The weather is nice and sunny for the most part, the city is quite dense, and there is a good diversity and mixity of land uses in several parts of the city, like in Hamra, in Gemese, and in Mar Mikhail. So these are all factors that could promote walkability if other challenges are properly addressed.
Actually, since 2012, several studies were completed for several beneficiaries in order to improve the walkability of the cities. These studies were approved by the beneficiaries and were funded by several sources, World Bank, AFD, and others. The problem was the governance issue, because there is no decision at political level to move toward a walkable city. Now we have an opportunity with the crisis to give the chance for the non-motorized mode.
Many cities have traffic models that they use to analyze vehicular traffic on highways and roadways during different times of the day, or to forecast how infrastructure changes or new investments into roadways impact traffic. What we have tried to do here is estimate that for pedestrians, to build a detailed pedestrian flow model for Beirut that explains different levels of foot traffic on individual sidewalks and city streets during different times of the day. We also collected pedestrian counts at around 90 locations throughout Beirut to calibrate this model and to make sure that the forecasts it provides correspond to actual levels of foot traffic on city streets. Once we had a calibrate pedestrian flow model, we could use it to test various scenarios. These design ideas that came out of a community workshop we conducted last summer were used to evaluate how different changes on sidewalk qualities, public spaces, traffic calming projects, better intersection designs, and so forth would actually change pedestrian accessibilities and disrupt pedestrian flows on city streets, desirably improving pedestrian walkability environments in Beirut.
In response to the blast, a team of researchers from MIT and the American University of Beirut have been collaborating to re-envision the blast-affected neighborhoods with proposals to improve streetscapes and create a network of community streets. We use urban network analysis tools to model pedestrian trips in the area and to prioritize the selection of design improvements. First, we model potential pedestrian trips between various origin-destination pairs, such as journeys from homes to parks, homes to schools, jobs to restaurants, and so on. Second, we collect pedestrian counts on the streets of Beirut at around 90 locations to calibrate the raw pedestrian flow estimates. The calibrated model results in estimated flows that closely match observed foot traffic on counted streets, while also providing a more expansive picture of pedestrian flows on all streets in the area during peak travel periods in the morning, lunchtime, and evening. Having built a model of pedestrian flows for central Beirut, we convened a stakeholder workshop with community groups, civil society leaders, and professionals at the American University of Beirut to identify important challenges to walkability in these neighborhoods and to propose improvements and future urban design interventions. Examples of interventions that participants suggested include improving stairways that help pedestrians navigate difficult elevation change, opening up existing or creating new parks, providing shuttle buses to take people up steep hills, planting trees, providing benches, increasing the widths of sidewalks, reducing parking, and others. The research team then synthesized the ideas into several actionable scenarios in order to analyze the pedestrian benefits of each of the proposed interventions. Based on these assessments, the project team first chose specific short-term tactical interventions that would immediately improve key walking routes in the area with minimal costs, such as improving sidewalks and pedestrian bridges along Charles Elou Highway, making them safer and more accessible, and improving access to the Quarantina neighborhood. We also propose a more pedestrian-friendly intersection between George Haddad and Garud Street by introducing a raised intersection and all directions signalized crossing for pedestrians, dedicated bus lanes, and more greenery. A longer-term strategy can also build on these tactical interventions, such as an even bolder vision to turn the Charles Elou Highway into a more humane urban boulevard, or establishing a large new city park around the Mar Mihail train station. We used the pedestrian flow model to test how the suggested changes and interventions within each scenario would affect pedestrian accessibility to different daily destinations, and how these interventions would restructure the distribution of pedestrian flows on city streets, desirably increasing pedestrian journeys in the city. The maps here illustrate in red where a specific urban design scenario is increasing foot traffic on streets, and in blue where some pedestrian activity is decreased due to newly introduced destinations that can attract pedestrians away from existing areas. This kind of modeling helps provide metrics and visualizations to translate community priorities for policy experts and decision makers, illustrating the public benefits of specific urban design interventions like increasing street safety and accessibility, adding more ground floor retail space, or improving public transit access. Pedestrian modeling and urban design impact analysis can play a critical role in effective disaster relief and in improving a city's critical infrastructure. We see great potential in the interplay of the insights of pedestrian modeling and collaborative community decision-making. Implementation of soft mobility and public transportation will still require political will and addressing complex challenges related to funding, demand for parking, and political resistance. Yet, with a better understanding of how we move within our cities, we can identify challenges and opportunities, make relevant findings tangible to a wider audience, and create a more transparent process for community and stakeholder engagement in working towards holistic change, integrated and inclusive urban design and planning decisions.